The moon's origin, how it shaped Earth's history. The moon has been a long-standing companion to Earth, an awe-inspiring celestial neighbor that has illuminated our nights and sparked human imagination for millennia. But behind its serene beauty lies a story of profound cosmic events and immense impact. This video guides us through the moon's origin, its scientific significance, and the pivotal role it has played in shaping Earth's history. The story of the moon begins over 4.5 billion years ago, during the tumultuous early days of our solar system. Earth, still young and forming, collided with a Mars-sized object scientists call Theia. This cataclysmic event, known as the giant impact theory, caused material to be ejected into space. Over time, the debris from this collision coalesced and gave rise to what we now know as the moon. This theory finds support in key evidence, such as the similar isotopic compositions of Earth's crust and lunar rocks, indicating both bodies formed from the same material. The aftermath of the collision not only created the moon, but also transformed the Earth, setting it on a path to stability that allowed for life to thrive. One of the moon's most crucial contributions to Earth is the stabilization of its rotational axis. Earth's axial tilt, currently at 23.5 degrees, is responsible for the planet's seasons. Without the moon, gravitational interactions with other planets in the solar system could cause Earth's tilt to vary wildly over time. Such extreme shifts would destabilize Earth's climate, alternating between long ice ages and scorching heat. The moon's gravitational pull acts as an anchor, ensuring relatively steady seasons that have supported the evolution of a stable climate and life itself. The gravitational pull of the moon does more than stabilize Earth. It also controls the tides. By pulling on Earth's oceans, the moon creates the rhythmic rise and fall of tides that are vital for life on Earth. Tides shape coastal environments, influence oceanic currents, and even impact marine life cycles. In Earth's early history, the tidal zones fueled the development of primitive life forms. As tides ebbed and flowed, they mixed nutrients, oxygen, and minerals, creating a dynamic environment where life could take its first steps. The moon has also slowed Earth's rotation over billions of years. Early in Earth's history, days lasted as little as 6 hours. The interaction between the moon's gravitational pull and Earth's oceans dissipates energy as tidal friction, gradually extending the length of our planet's day. Today, a complete day lasts 24 hours, a shift that has profoundly influenced the daily rhythms of life. This increase in day length may also have created favorable conditions for more complex organisms to develop, as it brought longer and more predictable periods of light and darkness. It's worth considering a scenario where Earth never had a moon. Without the moon's stabilizing force, Earth's axial tilt might have oscillated wildly, leading to unpredictable and extreme climate shifts. In such a chaotic environment, life might never have evolved, or, at the very least, would look vastly different from what we know today. Without the moon's influence on tides, oceanic ecosystems might have lacked the dynamism that fueled the evolution of early species. Earth's rotation would also remain much faster, resulting in shorter days and nights, altering the fundamental cycles that govern biological growth and behavior. Beyond its role in biological evolution, the moon has played a subtle but critical role in shaping Earth's geology. Lunar-originated tidal forces contribute to erosion and the transportation of sediments, sculpting coastlines and carving river channels. Over time, these processes have helped shape the landscapes we see today. Impact events involving meteor showers have also left their mark on both Earth and the moon. Many craters on the moon stand as a record of these impacts, providing scientists with insight into the early bombardment phase of Earth's history. These events left geological imprints that shaped Earth's surface and influenced where ecosystems could develop. The moon serves as a cosmic time capsule, preserving clues about Earth's infancy and the solar system's formation. Unlike Earth, where plate tectonics and weather erode ancient materials, the moon's surface has remained relatively unchanged for billions of years. The lunar samples brought back during the Apollo missions have offered invaluable insights into Earth's origins, the giant impact event, and the timeline of planetary formation. Studying moon rocks has also helped scientists refine their understanding of the solar system's early environment, including the abundance of volatile materials like water, which may have been delivered by early asteroid impacts. The moon's regular phases and mesmerizing eclipses are more than optical wonders. They've played a role in cultivating life and culture. The lunar cycle, lasting about 29.5 days, influences behaviors in certain species, particularly in marine environments where phases of the moon correspond to tides. Eclipses, a celestial alignment of the sun, earth, and moon, have also had profound scientific and cultural importance throughout history. Ancient civilizations viewed them as omens, while modern astronomers use them to study atmospheric and orbital phenomena. From ancient mythologies to modern space exploration, the moon has always been central to human curiosity. It inspired early astronomers to develop calendars and guided explorers with its phases' consistency. The Apollo program in the 20th century marked a turning point as humanity set foot on its surface and brought back tangible proof of the moon's connection to Earth. Today, space agencies view the moon not just as a scientific frontier, but also as a gateway to further exploring our solar system. Lunar missions continue to expand our understanding of Earth's cosmic neighborhood. Even as it exerts its powerful grip on Earth, the moon is drifting away. It moves about 3.8 centimeters farther from Earth every year due to gravitational interactions. This retreat may seem minor now, but over millions of years, it could significantly affect tides and Earth's tilt. Eventually, this will alter the delicate balance we've relied on for so long. However, the timescale for such changes spans millions of years, giving us plenty of time to study and adapt to these shifts. The moon isn't just a relic of Earth's history, it also holds the key to humanity's future. Space agencies around the world are exploring its potential as a base for deeper space missions. Its resources, including water ice and minerals, could support human outposts or facilitate fuel production for journeys to Mars and beyond. As we continue to blaze new trails in space exploration, the moon could serve as a stepping stone in humanity's journey to become an interplanetary species. The intimate connection between Earth and the moon illustrates the delicate balance that sustains life. From stabilizing Earth's axis to shaping its shoreline, from lengthening our days to fostering evolved ecosystems, the moon's influence touches every aspect of our planet's story. Even now, its gravitational pull reminds us of cosmic connections, how celestial bodies interact to create environments that nurture and sustain life. By studying the moon, we not only understand our planet better, we also gain tools for exploring worlds beyond. The Earth-Moon system serves as a unique model for planetary scientists seeking insights into the evolution of other moons and planets. Comparing Earth's moon to others, such as Europa or Titan, helps us refine our search for habitable environments across the solar system and beyond. It's another reminder that studying our own backyard is crucial for interpreting the broader cosmic landscape. The moon's story is one of transformation and interconnection. Born from chaos, it became a stabilizer of Earth's axis, a regulator of tides, a catalyst for life, and a guide for human exploration. Without it, our planet would be an entirely different world, perhaps one where life never took root. As you gaze at the moon, take a moment to marvel at its enduring influence, not just on Earth, but on the story of life in the cosmos. It's a profound reminder of how interconnected and dynamic our universe is, a system where even the smallest changes ripple across time to shape what we know today.